So let's imagine that we are in the ocean and we're going to think a little bit about fish. And we know that organisms usually are not just by themselves, that there's other organisms around. There might be other members of their species around, and there are very likely going to be other species around. What we're going to focus on in this video is those interactions within a species and between species. So, for example, let's say that this white species right over here likes to eat this yellow species for food. That is an interaction. It'll try to predate, to eat that yellow species. So that type of interaction that is between species we call interspecific interactions. And this particular interaction that we are seeing is one of predation. One species is using the other species for food. Now, that's not the only type of interaction, just in this very simple picture. You could imagine there's only one little yellowfish here, and both of these white fish are hungry. They're going to need to compete to see who gets that yellow fish. So between these two fish, you could have another type of interaction, and that's competition. But this is competition between two members of the same species. So this is intraspecific interaction. In particular, it's competition. I could just write interaction, but I'm being more specific here, that is competition. And one way to think about it, when people say intramural sports, they're talking about playing people in your same school. That's what's going on here. You're competing against other fish in your same species. Now, you can also have competition between species. For example, maybe this blue fish right over here, try to make this one look a little bit different. This blue fish also likes to eat this yellowfish species. So you have interspecific interaction between the blue species and this yellow fish. But you also now have interspecies or interspecific interaction or interspecific competition between this white species and this blue species. Now, competition is really interesting because you can imagine the more of a species that there is around, the more competition that they're going to give, not just for other species, but for each other. So usually as population density goes up, that competition goes up, and though the resources that are available for any one individual might go down. So it can be a little bit of a check, or in many cases a very big check, on the population or the population density. And now you can imagine situations where one species is better at competing for resources than another species. Well, then it's going to start to become more and more common relative to that other species. And you can imagine an extreme situation where it outcompetes in every dimension. And at that point, you have what's called the competitive exclusion principle, where they're essentially in the same niche, and this white species would essentially take over that niche. But we also know that just because they're competing for resources, don't mean that both species or multiple species can't be in that same ecosystem. And this especially happens through something called resource partitioning. So let me give a very simple example here. Resource partitioning. Let's imagine creatures living in a forest. I'll draw one of the trees of that forest. And you might say, all right, there's multiple creatures who like living on trees. Maybe one of the species just overtakes the tree. But it turns out that different parts of that tree might be good for different creatures, where different creatures have different advantages in different parts of the tree. For example, the top of the tree might be sunnier and drier. And so there might be creatures that can outcompete in the sunny and dry part of the tree, while maybe the base of the tree down here is more damp and wet and shady and not getting as much sun. Let me draw that I'll draw it in a brown color right over here, not getting as much sun. And maybe there's a different species that could do well over here. And it's unlikely to just even have two species if we're thinking about a tree. There could be 50 species that are living here, but they're living in different parts of the tree. And it isn't just about being in different parts of something. It could also be at different times. Maybe one species can outcompete at night and another species can outcompete in the daytime. That is also resource partitioning. But the big takeaway from this video is that organisms are not in isolation. They're interacting with other members of their same species and with other species. There could be extreme situations where one species can win out in every dimension, in which case the other species might not be able to stick around in that niche. But there's other situations, and this is very common, where species can share a resource because they can outcompete or they can thrive in different parts of that resource. They've essentially carved out their own niche using different parts of, in this example, this tree.